Hi, I'm Shaul Amir, working as a professor in EC department, Sales Institute of Technology, Karyapati. This session we are going to discuss about Routh array problem, which will come under linear control engineering. So I'll read the problem statement. The open loop transfer function of unity feedback control system is given by g of s is equal to k divided by s plus 2 into s plus 4 into s square plus 6s plus 25. By applying the Routh criterion, discuss the stability of the closed loop system as a function of k. Determine the value of k which will cause sustained oscillations in the closed loop system. What are the corresponding oscillating frequency? So here they have given open loop transfer function and the feedback is unity. Now we have to find out the closed loop transfer function, and then we have to find the characteristic equation and then form a Routh array. Here we have to find the range of value of k so that the system is stable. So I start with forming a closed loop system and then forming Routh array. So closed loop system transfer function can be determined by C of s by R of s equal to G of s divided by G of s H of s is equal to 1, and this is unity feedback system. Now instead of finding closed loop transfer function directly, we are finding the characteristic equation, that is denominator which is equal to 0 in the transfer function. Denominator is equal to 0, then it is called characteristic function. Here the characteristic function is 1 plus g of s, okay, and I'm going to substitute g of s in this equation, and I'm going to make this is equal to 0. I'll get 1 plus k divided by s plus 2 into s plus 4 into s square plus 6s plus 25, which is equal to 0. Now I am cross multiplying it and making is equal to 0. I will get s plus 2 into s plus 4 into s square plus 6s plus 25 plus k is equal to 0. Now I am multiplying these two polynomials. I get s square plus 6s plus 8, because s into s square, s into 4s plus 2s plus 4 into 2 8. So 4s plus 2s is equal to 6s. So s square plus 6s plus 8, and then I am multiplying this term and this term plus k is equal to 0. So when I am multiplying, I get s power 4 plus 6x square plus 25s square plus 6s cube plus 36s square plus 150s plus 8s plus 48s plus 200 plus k is equal to 0. I'm going to combine similar powers, so I'm just taking 6x cube and then 6x cube, so that is 12s cube. That is first term is s power 4 plus 12s cube, and then s square. So we have 25s square, 36s square, and then 8s square. When I am adding all these things, I will get 69x square plus I have s terms 150 plus 48. So 150 plus 48 is 198 s plus the remaining 200 plus k is equal to 0. So this the highest order of the polynomial is power 4. So s power 4, this is even, and we have to make a Routh array. So we are forming Routh array. First I am taking even power. So even powers are s power 4 and then s power square, s square, and then the constant. These are all even power. Odd is 12 and 198. So I am writing first row s power 4 is 1 and 69, then 200 plus k, and then s cube. So I have to write odd coefficient, power coefficient, that is 12 and 198. Now I have to form the third row. Third row can be formed by multiplying 12 and 69 minus 198 into 1 divided by 12. So I have written here, yes, 12 into 69 minus 198 into 1 divided by 12. So when we are calculating, we get 52.5, and then we have to write the second row. Second row can be formed by multiplying 12 and 200 plus k minus, here we are assume the 0 into 1 divided by 12. So 12 into 200 plus k plus 0 divided by 12. So we cancel out 12, then we get 200 plus k. So 200 plus k, the second element of the third row, that is 52.5 and 200 plus k. Now we have to form third row. Third row can be formed by multiplying 52.5 and 198 minus 200 plus k into 12 divided by 52.k. So I have written here, so I am just multiplying 52.5 and 198, I get 1395. 12, I am just multiplying inside the bracket, I get 12 into 200 is 2400 minus 12k divided by 52.5. When I am subtracting these two things, I will get 7995 minus 12 divided by 52.5. I am just writing this here, third row, and fourth row. In fact, the fifth row, s power 0 row, I have to form by multiplying this element and this element. Okay, then I have to assume that is 0, then minus 0 into 52.5 divided by this element. So I have written here. Okay, so when we are multiplying these two things divided by this element, we get only this. Okay, 200 plus k, because here it is 0. So when we are multiplying these two things, we'll get 0, and this one and this one divided by this element. So this element, so these two will get cancelled. We get 200 plus k, that is, I am writing like 7995 minus 12k cross 200 plus k divided by 7995 minus 12k divided by 52.5. So I can cancel these two things, I get only 200 plus k. I have written 200 plus k. So this is the Routh array. Now we have to analyze for stability. For stability, if the system is said to be stability in the Routh array, when we are seeing the first column of the Routh array must be greater than 0. There should not be any 0, there should not be any negative values. So we have to analyze this one, and we have to find the value of k so that the system is said to be stable. For that, we have to take s power 1 row and s power 0 row. In fact, yes, this row also, because there should not be any zeros in the first row, and also there should not be any negative values. For that, we are going to take and we are going to solve for k. So for the stable system, so what I told, I have written here, there should not be any sign changes, and also there should not be any 0 in the first column of the Routh array. So I have taken third s power 1 row, this equation, and I am going to make this should be greater than 0. So I am 7995 minus 112k divided by 52.5 should be greater than 0. This is one condition, and also the last row 200 plus k should be greater than 0. So we have to solve for these two conditions. If the system is satisfying this condition, we can say that the system is said to be stable, because if the system meet or the k meet this condition, the first column of the Routh array become positive. So we are going to solve for this. So I am just taking the first one, 7995 minus 12k divided by 52.5 is greater than 0 for this. So is greater than 0, the denominator part becomes 0, because if I am multiplying 0 with 52.5, I'll get 0. So I'm just taking like 7995 minus 12k is greater than 0. Now I'm dividing the entire row equation by 12. I get, when I am dividing 7995 by 12, I get 666.25 minus k is greater than 0. I am moving k right hand side, so like minus k become plus. So 666.25 is greater than k, hence k is less than 666.25. Similarly, I am solving with the second equation. Here 200 plus k should be greater than 0. When I am moving 200 right hand side, okay, I get k is greater than minus 200. Practically the gain value start from 0. Okay, there should not be any negative value, so we can assume that the k start from 0, and in fact there should not be any 0. It should be greater than 0. K should be always greater than 0. So for stable system, the range of k value should be, one is I got it from this one, that is 0, starting from 0, less than k is less than the second one, 666.25. So this is the possible values of k, so that the system is said to be stable. This means in this range the system is a stable system. If it is beyond that range, the system may not be stable. And also we have to find the we have to find the roots. Okay, so already we told that this is the range, and we have a possibility that when k is equal to 666.25, this is a special condition. Okay, if it is less than 666.25, there will not be any problem. If it is exactly equal to 666.25, then s power 1 row becomes 0, which indicates the possibility of roots on imaginary axis. Hence we have to solve for this, and we have to find the roots on imaginary axis. So so I'm taking previous row, that is S1. I have analyzed s power 1 row, so I'm taking the previous row and I'm forming auxiliary equation. So s power 2 equation, that is row, saying 52.5 and 200 plus k. So this is s square and this is s power 0. I am forming auxiliary equation like 52.5 s square plus 200 plus k is equal to 0. So here I am going to substitute k is equal to 666.25. I am just substituting and finding and find the value. So 52.5 s square plus 200 plus 666.25 is equal to 0. So when I am adding these two things, I get 52.5 s square plus 866.25 is equal to 0. I am moving 866.25 right hand side. I get 52.5 s square is equal to minus 866.25. So s square is equal to, I am just dividing this by this one. Okay, so minus 866.25 divided by 52.5, which is equal to minus 16.5. If s square is equal to 16.5, then s is equal to plus or minus square root of 16.5. So here I have a negative square root. So when I am taking square root of j, I get square root of minus, I'll get j. So plus or minus j square root of 16.5, which is equal to plus or minus j. When I am taking square root of 16.5, I get 4.062. So I can say that s is equal to j 4.062 or minus j 4.062. So this is nothing but omega, because s is equal to j omega plus or minus j omega. So omega value is 4.062. This is the frequency, this is oscillating frequency. Hence the frequency of oscillation is omega is equal to 4.062 radians per second. So with this I am stopping, and if you have any queries you can post in the channel. We will clarify it. Thank you very much.